Hello everyone, this is Bo. Welcome to the number representation assignment discussion. This assignment, there are 3 questions. You're asked to develop. There are 3 questions. You're asked to develop 3 functions in these 3 questions. And if you have all of them right, you will get 42 points of 60 points. In question 3, you are asked to do some comment. So this part will be hand graded. So that's notation for this assignment. Next, we are going to focus on the questions. In question 1, usually when we use a numerical algorithm to solve specific computational problems, the associative and distributive property may not hold. The purpose of this function is to check the correctness Okay, so the function's name is check arith axiom. There are 3 inputs. A, B, and C. They are all double arrays, and they have the same amount of elements. Okay, and the output argument of this function is A1, A2, A3, A4. Among these 4 arguments, A1 A2, A3 are ratios. So they're less than 1 or equal to 1. To solve this, to develop this function, for loop may be used to loop each element of A, B, and C, and to judge if the property is whole. I think you would use not equal or equal. Okay, so for A4, F4 is a char array. So you may use a function integer to string to transfer the number to characters. These are the hint for question 1. In question 2, you are asked to develop a function named hex2bin. The purpose of this function is to convert a hexadecimal string to its binary expressions. And the input argument of this function is h. H could be one, two, three, four, 5, 6, 7, 8, 9, and capital A, small a, capital B, small b, capital C, small c, and capital E, and the small e, capital F, and small f. They are all characters. And be careful here. Small a and capital A, they all represent 10 in hexadecimal expression. Okay, so you may use string to double this function to deal with a numbered character. So to know more about this function, you may type help string to double in the command window. The basic idea of this function is, for example, string to double 2 gives you a 2. Okay, so by using this function, you can easily transfer those number character to numbers. Okay. You may use a switch case here because capital A and small a. In this case, if the input are capital and small a, then they represent 10, right? So you may use a switch case to get this condition. And for input capital B or small b, you should transfer capital B and small b into 11, and so on. The output argument, the output argument is a 1/4 logical array. So I suggest you to use false and true for the assignment. Because they are 1 by 4 logical array. Okay, so the initial assignment for B is false, 1 by 2, right? And to assign B to get the new B, you first need to check if the first element of B should be changed into true. Then the second. Third and fourth. Okay. You may use a for loop and if condition to assign to judge if the element of B at one position should be changed. Okay. So these are hint for problem 2. Then let's go and have a look at problem 3. In question 3, from the video, we already know that the storage of double data for a double data, it needs 64 bits, and the first bit is psi, and from 2 to 12 it is their exponent, and from 13 to 64 their fraction. Okay. In this question, you are asked to develop a function to find these 64 bits of a double data. Okay. The function's name is number to IEE. Let's look at the input argument. The input argument is double data, and the output argument is has let me see how many components. 4 components. S is the sign. It is 1 for minus and 0 for positive. And the second output is an logical array E. It has 11 elements. 11 elements logical array. And F is 52 elements logical array. Okay. And the E10 is 10 base value of E. To develop this function, the first step is to use a function named number2 hex. If you have no idea about this function, please command help number2 hex. The basic idea of number2 hex function is to convert singles and doubles to IEEE hexadecimal strings. Okay, so in our problem is convert doubles, the input, to its IEEE hexadecimal expression. Okay, what is IEEE hexadecimal string? Is a good question. So you have to know hexadecimal strings at first. Hexadecimal string is for double data, it is a 16 char array of hexadecimal floating point representation. Okay, for example, number2 hex 1. Okay, 1 is double data. 1 has a class of double, and the number2 hex 1 will give you an expression 3FF then 13 0. Okay, it is I'm not sure how many zeros I just typed, but the total is 16 bits. Okay, so this is a hexadecimal string expression. What is this 3 FF and all 0 mean? You know, in hexadecimal expression, each expression can be transferred to 4-digit logical binary expression. In other words, all these 16 bits can be developed to 4 bits binary logical array. So the total bits could be 16 multiplied by 4. So we get 64. Finally, we get 64 bits. Okay, that's the idea. How to transfer this hexadecimal string to 4-digit binary logical array? We will use the function we developed in question 2. That's basically the idea. Basically the idea. So the next step is to use the function we just developed in question 2, it is what is the name of that function? Let me see. Oh yeah, hex to bin. Okay. So by using this function, we may, for example, this three, right? We may develop and transfer this 3 to 0, 0, 1, 1. Okay. So what is 0? Why 3 equals to 0, 0, 1, 1? Because because the first 1 is 1 multiplied by 2 exponent 1 and plus 1, so equals to 3. That's basically the idea. So after getting all 64 bits, we should assign the output arguments. E is the first digit, the first bit of this 64 bits, and just as I said, the exponent, okay, is from 2 to 12, and the fraction is from 30 to 64. Okay. What about E10? E10 here is a 10-base expression of E value, and not E value. S is from its first bit. E10 is the 10-base expression of this E. To get this E10, for example, if I have it just transfer the binary, the 2-base value to 10-bit value. For example, if I have but E has 11 elements. So to make it simple, I just do a simple example. Okay, 1, 1, 1. So in this case, this is a 2-base value expression. Okay, to transfer to 10-base value. So this 1 is in the position which has exponent 2 exponent 2, okay, plus this 1 multiplied by 2 has exponent 1 and plus 1. So the total, the sum of these 3 value equals to 7, right? So in this process, the 2-base value was transferred to 10-base value. Okay, so we'll get E10. Now I think you have all the output arguments. And if you get everything, have all these 3 functions right, you may get 42 points. And now the left points I need you to do some comment. Okay. In question 3, let's say comment. How to do the comment? I will give an example. Okay. In the first set, set 1, okay, it is the output is at E, F, and E10 equals to number 2 IEEE 1, and also you have a expression IEF E10 equals to number 2 IEEE 1 plus EPS 1, okay? So in the first expression, you will get S equals to 0 because you have a positive 1, right? So its sign is positive and you have the sign expressed as 0. And E equals to 0, 1, 1, 1. And how many 1? 10, 1. Okay. And for F, you have all the common 52 elements 0. And E10 is 1023. Okay, you will get this result. For the second expression, you will get you have to express, okay, to get 4 points, you have to explain those results. And the logic how to get this result. And you also should compare these two expressions and the result you got. What's the difference? So for the second expression, you probably will get the same S and the same E, but different F. Okay, you will have 1 at the end. Why you have 1? It is because you have EPS 1 here. If you, of course, you will get the same E10 because these two numbers, 1 and 1 plus EPS 1, they would to express these two numbers, you would have the same exponent. Okay, so the difference is just the EPS 1. What is EPS 1? If you type EPS 1, you probably will get 4.4 or 2.220684 E. You have the exponent minus 16. If you multiply this express 1 by 2 exponent 52, you probably will get 1 at last. It means it is EPS 1 is 1 of 2 exponent 52. Okay, just the distance between two numbers, which can be expressed in this double expression in MATLAB. Okay, so in this case, just you just have 1 at the end of F, just the fraction. You have a little difference. Okay, so you should comment and explain the difference of these two expressions. That's what you needed to do in question 3 about comment to get the 4 points. Well, I think that's all about this assignment. This is not a very difficult assignment. There are 3 functions, and you need do some comment. The comment will be hand graded, so don't worry if you say you cannot get the 60 points. Okay.